So it is really important that we understand how to find the greatest common factor to even set ourselves up for later on some of the factoring that we're going to do, because we're going to be using it along the way. So greatest common factor, also known as, you could put here, it will often be referred to as the GCF. Okay? So the greatest common factor, the GCF, when we're looking for the greatest common factor, what we're really looking for is the largest factor that divides out of each. So if you're looking for the greatest common factor of two terms, then you're looking for the largest factor. What is the largest thing that you can divide out of both of them? You can find the greatest common factor, though, of a group of six terms even. It's still always going to be the same. What can each of them be divided by? And then when I do divide that out, the results show me that there isn't anything else I could divide out other than 1. I wouldn't get anywhere. Okay? So an example, the GCF of 4 and 12 is 4. 4 divided by 4 is 1. 12 divided by 4 is 3. Now I look at that 1 and that 3 right here and I say, is there anything else that both of those could be divided out? Something that could be divided out of both of them other than 1? No. So since I can't, since no other integer other than 1 can be divided out now, I'm going to say, I guess the greatest common factor of 4 and 12 is going to have to be 4. Okay, so let's do some practice here. Number 1, 15 and 40. What do you think is the GCF, the largest factor that could be divided out of both of those? And sometimes you may not get to it right away at the first stab that you may get it. But if you know that something that both of them are divisible by, start there. So do you know anything that both 15 and 40 are divisible by? 5. Okay, so let's take 15 and divide it by 5. So we're thinking right now it might be 5. Okay, so 15 divided by 5 and 40 divided by 5. So what is 15 divided by 5?
3.
3. And 40 divided by 5 is?
8.
8. Okay. How are you feeling about the results now, 3 and 8? Is there anything else that we could divide out of 3 that could also be divided out of 8?
1.
1. Remember, 1's not going to get us anywhere, so we're not even going to state that. Other than 1. No. 3 is a prime number, isn't it?
Yes.
Okay, so here's where prime comes in. 3 is a prime number, so we know that 3 is not divisible by anything other than itself and 1. So then the real question we ask ourselves is, can you divide a 3 out of 8?
No.
No. So our GCF is 5. Okay? The greatest common factor of those two numeric terms is 5. How about number 2? First of all, are either of those numbers prime?
Yeah.
Which one for sure you're pretty convinced is prime?
13.
13? 13 is not divisible by anything except itself and 1?
Yep.
Okay, so then that means now the only other test we have to do is, does 13 go into 39?
Yeah, it does.
How many times?
3 times.
So it looks like maybe 13 could be our, let's check and see if 13 is. So 39 divided by 13, you just said is 3. And 13 divided by 13 is what? 1. So now we look at our results over here. We have a 3 and we have a 1. Is there anything we can divide out of both of those that will get us anywhere?
Nope.
No. So our GCF is
13.
13. Okay. The next one, 30 and 75. You don't have to find the GCF immediately. Instead, what you should be starting to think of are some of those, I can't say the word, divisibility rules that you learned in elementary school, if you remember them. If the numbers end in 0 and 5, they're both for sure divisible by 5. Yeah, so let's try that. Let's start there. Let's say 30 divided by 5, 75 divided by 5.
6 and
So 6 and 15. Okay.
3 and 19.
Are we done, do you think? So let's go like this, say, not done, because 6 and 15 are both now divisible by something other than 1. So now we're going to say 6 divided by 3, 15 divided by 3, 6 divided by 3,
2 and 5.
2, and 15 divided by 3 is 5.
And 2 is a prime number.
So now we look at these guys. 2 is a prime number. Does 2 go into 5? No. So are we done?
Yes.
Okay, what do we have to do though? We actually divided out 2 of them. So we have to take,
GCF is 5 and 3.
so the GCF is 5 times 3. So since we divided by 5 and we divided by 3, in reality, we could have went straight to dividing by 15, couldn't we? But sometimes we don't know that. So in other words, 15 would have gone into 30 how many times?
2 times.
2 times. 15 would have gone into 75 how many times? 5 times, yeah. Those the results that we got there? So our GCF is 15. Sometimes it just takes us a while to get to it is all. Okay? We don't go directly there necessarily, always. Okay, how about 14 to 35? Where should we start, Faith? Give me a number you think might work, other than 1. 7? Okay, so 14 divided by 7. 35 divided by 7. How many 7s in 14, class? 2. How many 7s in 35? 5.
No other ones.
Yeah, that's the result we just got in the last one after our second division. We got 2 and 5 and we decided we were done, right? So our GCF is 7. You can't quit too early though. Make sure that you're dividing enough times, okay? Now we're working with just numbers now. So this part, we first of all got to get a good grasp on the numbers, and then we will be adding some variable parts to our terms also. 12 and 49.
12 doesn't go into 49.
But 12 isn't prime.
No. But
What does go into 12?
3 and
3, 4, 6, 2. So it's kind of like now we're asking ourselves, can any of those numbers go into 49? How about 2?
No.
No. 2 into 49? Not even. How about 3?
Yeah, possible.
Why don't you go ahead and try it?
Only
49
7.
divisible by 3?
7.
No.
7.
It doesn't go in there nicely, does it? How about 4? Yeah, how about 6? 6 go into 49? 6 times 7 is...
That's 48.
That's 48. 6 times 8 is 48.
7 times 7 is
7 times 7 is 49, but does 7 go into 12?
48.
No.
No.
What do you think? Even though they're not both prime numbers, in fact, neither of them is it? We already named some things that go into 12. We've already named some things that go into 49, like 7.
You have a decimal point going
No, we want integer results. So what do you think? Do you think we can divide anything out of both of them other than
No, this is the
1?
number.
Okay.
1.
So let's put that can't. So we have this in our notes. Can't divide out anything except 1. So if we have to claim that there's a GCF, we have to say it's 1, which is kind of worthless. But So we don't typically even bother factoring out the GCF if it's 1 because it isn't going to get us anywhere. Okay, so keep that in mind. Sometimes there isn't a GCF other than 1, and we call one a GCF of 1 pretty worthless. Doesn't get us anywhere. So any questions on this front side where we were just working with the number terms? Okay, here's where the challenge begins now on the back side. Finding the GCF of monomials that have variable parts. Okay, so example 3x and 9x squared. If I ask you to give me the GCF of 3x and 9x squared, those two monomial terms, you better answer 3x. And here's why. Because we know, we look at it and we say 3 and 9 are both divisible by what? 3. X and x squared are both divisible by just an x, because there aren't enough x's in the 3x to take out more than just an x. So we end up saying that GCF is what we can divide by is 3x. So then 3x divided by 3x, anything divided by itself is 1. So that's where the 1 came from here. 9x squared divided by 3x. Well, 9 divided by 3 is 3. And x squared divided by x. So think of it like this. We have x squared upstairs, and we have an x downstairs. What can we do? We can cancel one of them, can't we? And we end up with an x. So this gets a little trickier, but we're going to break it down a little bit more, okay? So 8y cubed and 4y. We're always going to work with the number parts, and then we're going to work with the variable parts. Okay, so would you write down, oh, I already had that, don't do that. Oh, what am I doing here? I already had that. Guess I still have a frozen brain from shoveling this morning. Okay, the GCF of 8 and 4 is, and this is our workspace. What do you think it is?
4.
4, okay? So let's go and do our dividing. 8 divided by 4. Now, we're not always going to show this dividing, but today we're going to, because it'll help us get it planted up here in our brain, how to go about this without showing words. So 8 divided by 4 and 4 has to be divided by 4. Those are our two terms, so no different than on the front side. So 8 divided by 4 is 2, and 4 divided by 4 is 1. Is there anything else that we can divide out of 2 that can also be divided out of 1? That's going to get us anywhere. Okay? So we're feeling happy about the fact that the number part of the GCF is 4. Now we're going to do the y cubed and the y. What do you think is the GCF? What do you think we can divide out of both of them, Michaela?
Okay, I have a question. Can we just like subtract it pretty much? Like it's just like crossing it out, but instead of just like
Using the property of dividing, which says subtract the exponents, yeah.
like 3 minus 1, so then it would be 2.
Okay, but I want to know, what are we going to divide by first? What do we think is the GCF of the variable part?
1x, or of y.
Just a y, right? Which is a y to the first power. Which you're just getting a step ahead, is all, Michaela. So the GCF of y cubed and y we think is y. So we're going to take the y cubed, and we're going to divide it by y. And this is where the subtraction comes in, doesn't it? Because this is y to the what power? First power. So 3 subtract 1 is y to the second. Yeah, y to the second. And then we're going to do the y and divide it by y.
Equals y to the first power.
No,
No, it equals one, just y.
no,
0.
1. Anything divided by itself except 0, the only one that can. Anything, I don't care what it looks like. It could be wxyz to the 4th power divided by wxyz to the 4th power. Anything divided by itself is 1. So y divided by y is 1. Now here's where it's really important for us to stop and look and say, is there anything else that I could divide out of y squared that I could also divide out of 1, other than 1? What do you think? Is there anything else that could be divided out of 1, that could also be divided out of y squared, other than 1? No. So now we say, okay, well then we did come up with the GCF of the variable part. So just like we did on the front, when we factored out a 5, when we divided out a 5, and then we divided out a 3, we did it in 2 steps, remember? We had to multiply them. So 4, our first GCF part, and the y have to be multiplied by each other. So 4 times y
For Y.
is 4y. So we're going to say
GCF.
the GCF is 4y. Now, notice, we don't have to even do the dividing up here, you know, like the saying, well, I guess we didn't. Don't even talk about it, Terry. Okay, so all we have to do is find out what's the monomial term that we can call the GCF. Okay? So again, every time you do these problems in your homework today, this is what you need to be doing, is showing the division like this, and then the multiplying at the end. So 15m cubed and 25n squared. Well, the GCF of 15 and 25 is, what do you think it is? 5? Okay, let's try it. So 15 divided by 5 and 25 divided by 5. The results are what, Claire Ann? No, 15 divided by 5. Help her out, someone. 15 divided by 5. 3. 25 divided by 5. 5. Okay, now we ask ourselves, did I really get the largest number that could be divided out? By asking, is there anything that could be divided out of 3 that could also be divided out of 5?
No.
No. So make sure you always stop and ask yourself that question though. Do not be happy with that it was just divisible by something. You still have to stop and ask yourself, is there anything that I can do yet with that 3 and that 5? No, so we'll circle our 5. We'll say we're happy with that. Then we're going to do the monomial part of the term, or the variable part of the term. So the m cubed and the n squared. So the GCF of m cubed and n squared is
M.
M3.
something that's going to be able to be divided out of m cubed that can also be divided out of n squared.
1.
1. Isn't this like that 12 and that 49?
Yes.
Can you can divide m cubed by some m's, but you can't divide it by any n's. You can divide n squared by some n's, but you can't divide it by any m's. So there's nothing they have in common. So we're going to say that it's 1. You know, sometimes the GCF is 1, as worthless as it is. And now we say, okay, well the number part GCF was 5. The variable part turned out to be 1, and 5 times 1 is
5.
5. So the GCF is just good old 5. There is not a variable part this time. Sometimes there can't be. Sometimes there can be a variable part, but there can't be a number part. So, okay, looks like we have one more to practice here. Okay, negative 4x to the 5th and 10x cubed. Okay, so what's the first thing we're going to write down that we're going to be looking for? We're going to look for the GCF of, remember, let's write this down. GCF of what? Just the number parts. Negative 4 and 10 is, what do we think it might be? 2?
2.
Okay. So now we show our dividing. We say, well, I got negative 4 divided by 2, and I got 10 that I have to divide by 2. And what's the result for each of those? So negative 4 divided by 2 is?
Negative 2 and 5.
Negative 2, and 10 divided by 2 is 5. Okay, is there anything else that can be divided out of both of them? Would get us anywhere?
No.
Okay. We will learn later that sometimes it's useful to actually divide both of them by a negative 1 Because we want one of them, the one that's negative, we want it to be positive instead. We'll learn that later though, okay? We won't worry about that right now. So, we're happy with our 2, aren't we?
Yep.
Okay, so now we're gonna look for the GCF of the variable parts. So the GCF of x to the 5th and x to the 3rd.
Is
In other words, remember x to the 5th means
x to the 5th power.
x times
X
X times x times x times x. There's 5 factors of x. And the other x to the 3rd means
X times
x times x times x. So there's 3 factors of x. So one of them has 5 factors of x, the other has 3 factors of x. What's the most we can take out
1.
of each?
Oh. 5 and 3 of them.
3.
There's
1.
5 x's in one of them, there's 3 in the other.
8.
3.
I heard it. 3, yeah, it's 3. Can't take any more than 3 out of 3, can you? How are you gonna, if I only get $3, how are you gonna get more than $3 out of me? Hmm? Okay, so we think it's x to the 3rd power. So now we're going to say, well, I got an x to the 5th that has to be divided by x to the 3rd, and I have an x to the 3rd that has to be divided by an x to the 3rd. Remember, we're dividing by what we think is the greatest common factor. Okay, here's our subtraction. X to the 5th divided by x to the 3rd.
X to the 2nd.
X to the 2nd.
And 1.
X cubed divided by x cubed?
1.
1. Anything divided by itself is 1. Now we say, is there anything else that could be divided out of x squared that it could also be divided out of 1 other than 1?
No.
1. So I'm thinking that we got a good GCF for our variable part. Now what do we do with those 2 GCFs? Take them times each other. So 2 times x cubed is
2x cubed.
2x cubed. So our GCF is 2x cubed. So we are going to, the first type of factoring we're going to learn how to do is factoring by the GCF. So we haven't even really started factoring polynomials yet today. All we're doing is learning out how to find, we're practicing how to find that GCF so that then we can start tomorrow by factoring using the GCF. Getting that unmultiplied name, remember that? So in other words, we got the products, and I said now in chapter 7 we're going to unmultiply. They're going to give us the product, and we got to know where it came from. So this is getting us ready for that. You need to take this seriously in this homework today. You need to make sure that you're understanding how to do it, and you're not just doing it to get it done. Okay, this is one of the toughest chapters, but yet is one of the most important things for you to move on in other math classes, is this factoring chapter. Okay, so we have to make sure we understand it. Anybody want to ask any questions about any of it that's still unclear to you that we practiced together here? Okay, then let's move on to homework.